So in this question, we have a 3x3 grid, and we're going to put 3A's, 3B's, and 3C's in the 9 spaces so that each row and column contain one of each letter. And we're given if A is placed in the upper left corner, we want to know how many ways, how many arrangements are possible. How many ways can we like put these 3A's, 3B's, 3C's so that, the conditions in the problem are satisfied. So to do this problem, the first thing you should notice is like you look at the answer choices, right? You see that the choices are 2, 3, 4, 5, 6. Those are clearly all very small answer choices. So that just tells us that clearly there are not very many possible arrangements. So as long as we carefully organize our counting, then we should be able to, easily count this. It shouldn't be too difficult as long as we stay careful and stay organized. So we're given that in this 3x3 grid, the letter A is at the top left corner. So we know that each row and each column contain exactly one letter. Well, if we're to look at this red column, we already have an A in the red column. And if we were to look at this red row, we also have an A in that row. So that means we cannot put like an A here or an A here or an A here or an A here. You're not allowed to put A's any of there because you already have an A in the top left corner. So we can ignore those. And we need to put 2 A's. So that tells us the 2 A's must go in this like this like red square kind of. So it turns out there are 2 cases, right? If the second A goes over here, then that means the last A has to go over here, just using like logical reasoning. And the other case is if you have a 3x3 square and the A goes here, and you look at this red square, if the second A goes here, then the third A must go here in order to have 1 A in every row and every column. So these are the only 2 possibilities for where you put the remaining 2 A's. And now we can take a look at like the B's and the C's, right? So we've taken care about all the A's. Now let's see where can we put the B's and the C's. So let's take a look at this like first arrangement here. If we were to take a look at this like blue column, we see that we already have an A, and we need to have a B and a C in that column as well. So there are 2 possibilities. The first case is if you have A, and if you have B, C. So that's the first possibility. The second possibility is like if you have like this. If you have A, and you have B, C like this, right? Both of these like work, right? In the first case, we have 1A, 1B, 1C in the first column. In the second case, we also have 1A, 1B, 1C in the first column. So now it turns out it's like quite simple, because if we look at the first case, like in this case here, if we were to take a look at this bottom row, you already have an A and a C, so this one must be a B. Here you have a B and an A, so this one must be C. Here you have an A and a B, so this one must be C. And here you have an A and a C, so this one must be B. So what that tells us is that once we've gotten like here, these black letters, A, B, C, once we got those fixed, the rest of the grid is already fixed, the red letters in that case. So here in this case, this yields exactly 1 possibility. And similarly, the second case also yields 1 possibility, right? This one has to be a C, this one has to be a B, this one has to be a C, and this one has to be a B. So everything is fixed. So this also yields 1 possibility. And now if we were to look at this second case back up here, again, we have 2 possibilities. The first possibility is if you have A, and you have B, C like this. And the second possibility is if you have A, or A, and then B, C like this, right? So with similar reasoning, those are the 2 cases. Then again, the entire grid is now fixed. If you were to look at the first one here, this first grid here, that we know that this one must be a B. That means this one must be a C. That means this one must be a B. That means this one must be a C. So like now this grid is also fixed. So there's exactly 1 possibility in this case. And if we were to look at this last case, as we expect, this grid is also going to be fixed. We know that this one's going to have to be a C this one has to be a B, this one has to be a C, and this one has to be a B. So there's also one possibility here. So now we've taken care of all of our cases. So we have 1 plus 1 plus 1 plus 1. And if we were to just do the simple addition, we would find that there are exactly 4 possible grids that satisfy the conditions in the problem. And that would be choice C, and we would be done.